Okay, so hyperbolas. Before we actually get into the formulas, and there's a lot of formulas for hyperbolas, we want to go over some of the, just the basics of it. So the very, very basic is the shape. We don't actually plot more than 2 points on the hyperbola itself. And then so we don't have to plot like dozens and dozens of points. We use what we call a guide box and asymptotes. And by drawing those, it gives us a guideline for how to draw the bells of the hyperbola. And the shape of the bells are not like a quadratic where a parabola is like tulip shaped. Think of it more of like a pasta bowl. So you've got a vertex and then it's kind of flat in the middle. And then as the arms curve outward, they actually get really, really straight. In fact, they get infinitely close to the asymptotes, which we're going to draw. So kind of a flat bottom and then gets infinitely close and the arms slowly get straighter and straighter and straighter. Okay, number 2, I'm going to give you the definition because I feel like I have to, even though it's not something I think you're required to memorize. The definition of a hyperbola is the set of all points, and ST stands for such that the difference between distances, to foci is a constant. So if you remember with ellipses, it was the distance to the edge of the ellipse and each foci was an addition of distances. So it was the sum. In this case, it is the difference of the distance that creates the hyperbola. And you can go on Google and there's all kinds of programs where they'll show you a hyperbola being drawn using string and other things if you want to see it animated. All right, so Roman numeral 2. There are 2 basic sets of equations for hyperbolas. The first one is for hyperbolas with a vertical transverse axis. Vertical transverse axis. And basically a vertical transverse axis means that the bells open up and down. That's a vertical transverse axis. All right, so the equation of a hyperbola with a vertical transverse axis is y minus k squared over a squared minus x minus h squared over b squared equals 1. So comparing that with our ellipse equation, first thing you notice, there is a minus sign in the middle, not a plus. They're both equal to 1. H is still with X, Y is still with K, but unlike an ellipse, the order is different. In a hyperbola equation, the a squared always comes first. It does not move around like it does on an ellipse. It always comes first. What changes is does X or Y come first? Oh. I'm sorry. No worries. All right, so I'm going to draw a line down here. So we're going to put our formula information down there. And over on the left-hand side, I want you to draw a pair of axes. So bring your Y in about the width of a ruler, maybe a little more. And then drop your X down below the hole in the paper. That will give you enough room. These do require more space than an ellipse. And so you're going to want to use your paper generously so you don't run out of room and have to redraw it. It's way too much work to have to redraw it because you don't have enough space. Okay, so let's go through the steps of what you need to do. Number 1, you need to find the center, and thankfully, it is still H, K. So in this case, my center would be, we're going to put our center at like 4, 4. So 4 to the right and 4 up. I'm going to label it capital C, H, K. We're just going to graph. This is just a diagram. It's not an example. It's just a diagram so we can label all the pieces and the parts. Okay, so you have a center. Number 2, In this one, the y squared comes first. So because it comes first, primarily it tells you that the bells are going to open up and down. But it also tells you that you're going to add and subtract A to the K coordinate. So it's going to go up and down. So from your center, let's say A is 3. So go up 3, 1, 2, 3, make a dot. Go down 3, 1, 2, 3, make a dot. These are your vertices. We're going to label them V sub 1 and V sub 2. And again, the distance from V sub 1 to the center is A, and from V sub 2 to the center is also A. Those are our vertices. Okay, number 3. The x squared comes second. So when the x squared comes second, it tells you that in the x direction are going to be the sides of the box. And in this case, it means you're going to add and subtract b to the h of the center. So let's say that b is 4. So count from your center 4 right and 4 left and make a dot. 1, 2, 3, 4. 1, 2, 3, 4. And again, that's a distance of b from the center. All right, with what we have so far, we are ready to draw the guide box. So your guide box is a box that basically fits around your vertices and where your B's are. So you go down and over and up and over, so that the vertices and your green B points are on the sides of the box. And I missed my vertex. Just a second. That's better. Okay, so we draw the guide box so that we can draw the asymptotes. So your asymptotes go from the corner of the box through the center to the other opposite corner of the box. They are dashed. They do need to stick out further than you think they do. So go generous on the length of your asymptotes and draw them both ways: the corner of the box, the center, and the corner of the box. All right, you have to, now we're ready now to actually draw in the hyperbola, the bells. So look up a second, watch me draw the first one. So here's the vertex. It's kind of flat. It skims the corner, and then it gets infinitely close to the asymptote without crossing it. It gets really straight. So again, it's kind of flat, skims the corner, and then gets infinitely close to the asymptote. Notice it doesn't encroach on the box. It's outside of the box. And then you do the same from this one. Kind of flat, skim the corner, infinitely close, kind of flat, skim the corner, infinitely close. All right, go ahead and draw your bells.
I see it from like 2 days ago, 3 days ago, when we got our 3-dimensional objects. Let's see.
All right, so let's talk asymptotes. Back in Algebra 1, you learned a line equation like what I have on the board. Y minus y sub 1 equals m times x minus x sub 1, also called point slope form because you have to have a point for x1, y1, and then you have to have a slope. For what we're doing today, I want you to remember that slope is change in y over change in x. The whole formula, remember, y2 minus y1 over x2 minus x1, but it's basically change in y over change in x. So what is the one point that both asymptotes cross through? Yeah, the center right there. So what we're going to use is the center for our point for both of them. That will simplify things. And then change in y and change in x, we're going to measure from the center to the corner of the box, and it's either going to be b over a or a over b. So let's write this down. So we're going to use the point h comma k, and then our slope for one of them will be a over b and the other negative a over b. So our combined formula is y minus k equals plus and minus a over b times x minus h. And then you have to solve for y. I might show you some shortcuts to this, especially if your asymptotes cross. If you drew them with a ruler, well, you can tell where they cross, and you can actually get y equals mx plus b on the first shot. We'll talk about that next week, though. So let's try to get our asymptote, or that's the formula. We'll do it later. Okay, so number 6, last thing is to get the foci. The equation for the foci is a squared plus b squared equals c squared. You remember the one for the ellipse was a squared minus b squared? This one's added. The foci lie on the transverse axis. They're along with the vertices. So they should be inside the bells, inside the curve part of the bell. And because you pass beyond the vertex, so if we put our focus like right here, let's call that S sub 1. And then from F sub 1 to the center is C. And then we'll put down here F sub 2. And from the center to F sub 2 is also C. So because it goes higher and lower than the vertices, C should be greater than A. So putting that together, our foci for a vertical transverse axis is h comma k plus and minus c. You find them, once you get c, it's exactly the same method as you use to find them for ellipses. Same exact method. Okay, I'm going to flip the page. We're going to go to Roman numeral 3, horizontal transverse axis. And we're going to go through the same formulas, but in less detail because you've already written down the basics. So horizontal transverse axis opens left and right, thus the name horizontal transverse axis. Okay, so the equation for a horizontal transverse axis is x minus h squared over a squared minus y minus k squared over b squared equals 1. And comparing it to the one that we wrote for the vertical transverse axis, you'll notice that a squared always comes first. There's still a negative, still equal to 1, but the x and the y have changed positions. All right, I'm going to draw again a line because I am spatially challenged. Okay, so the first thing you're going to find is your center, which is still h comma k. So over here, draw yourself, kind of move the y-axis over to the left a little bit. You can put your x in the middle. So just for the sake of this one, let's make our h comma k 3 to the right and 2 down. And that's your center, H comma K. Okay, number 2. In this one, the x squared comes first, which is why you know that the bells open left and right. But in terms of drawing the bells, you're going to add and subtract A to the H coordinate of the center. So let's make a 4. So we're going to go to the right, 1, 2, 3, 4, and to the left, 1, 2, 3, 4. We'll call the left one V sub 1, the right one V sub 2. And again, they are a distance of A from the center. Okay, number 3. The y squared comes second. So the sides of the box are going to be up and down. So we're going to add and subtract B plus minus B to the K of the center. Let's say that our B is 5. So we're going to go up 5, 1, 2, 3, 4, 5, make a dot, down 5, 1, 2, 3, 4, 5, make a dot. And again, that is a distance of B from the center. Hey, now that we've got our A's and our B's drawn in, we are ready to draw our guide box and we are ready to draw our asymptotes. So use your ruler and go ahead and draw the guide box and draw the asymptotes. Remember, the asymptotes go corner of the box, center, other corner of the box. Okay, so the equation for the asymptotes, we're going to still use the center as our 1 point. So y minus k equals, the difference is in this orientation, if I start at the center and go to the upper right corner of the box, I'm going up B and to the right A. So rise over run is going to be B over A. And then times x minus h. And then, of course, if you go to the other asymptote, start at the center, go to the left corner, you go up B and minus a to the left. So this is a plus and a minus B over A slope. Okay, foci. For the foci, same equation as the other one. A squared plus B squared equals C squared. So that hasn't changed. The biggest difference is, now let's draw our bells in, because we're going to need to draw the foci. So draw your bells in. So kind of flat, skim the corner, go very straight. Kind of flat, skim the corner, go very straight. Remember, think pasta bowl. Kind of flat, skim the corner, go straight. Don't cross the asymptotes. Kind of flat, skim the corner, draw the asymptotes. Or draw the curves. Okay, so your foci lie on the horizontal transverse axis. So you're going to go left and right. So in this orientation, foci go left and right. Again, C has to be greater than A because the foci are inside the bells. So let's put those on the drawing. F sub 1, F sub 2. And again, F to the center is a distance C, F to the center is a distance C. So in practicality, you're going to take your center point H, add and subtract C, comma K. Okay, one kind of random question that sometimes they throw in there is they want to know the length of the transverse axis. So your transverse axis goes from vertex 1 to vertex 2, whether it's vertical or horizontal. From vertex to vertex is your transverse axis. And since you start in the center and you go A to the right and A to the left, its length will be 2 times A because you have an A and then another A. So I'm throwing that one in there because that's a question you might actually see later. Okay, flip the page. We are going to do an example where we're going to use algebra to get the equation. You'll see it's very similar to ellipses, and then we're going to graph it. So here we go. I'm going to do an example. So 4x squared minus y squared plus 24x plus 4y plus 28 equals 0. In this form, the only thing you know about it for sure is it's not a parabola because an x is squared and a y is squared. Whether it's a circle, an ellipse, or a hyperbola, you're going to complete the square for x and y for all three of those. So that's where you always start. So let's group our terms. So 4x squared plus 24x, leave a space, minus y squared plus 4y, leave a space, and subtract the 28 over negative 28 space, space. So on the first x squared term, it's got a 4. We can't have a number on the x, so we're going to divide 4 out of the x terms. The 4 will go to the front, and then I've got x squared plus 6x. Leave a space. I have a similar issue with the y's. I can't have a negative 1y squared, so I'm going to divide both by a negative 1. So this becomes a negative, and then there's a parentheses, and then y squared minus 4y, leave a space, equals negative 28, space, space. All right, completing the square, magic formula is always b divided by 2 quantity squares. So 6 divided by 2 is 3, 3 squared is 9, so add 9, but you didn't just add 9, you added 4 times 9 because of the scalar. So you're going to add 36 on the right to keep it balanced, to keep it equal. This one, negative 4 divided by 2 is negative 2, squared is positive 4, but you didn't just add 4, you added a negative 1 times a 4. So you're going to subtract 4 on the right to keep it equal. Okay, so now complete the square. I have 4 times x plus 3 squared minus y minus 2 squared equals 4. If your 4 is positive, you probably are almost there. Because there's one negative and then 2 positive terms, it is most likely a hyperbola. But just like an ellipse, we need to force it equal to 1. So to force it equal to 1, we're going to divide the 4 by 4, and that means we have to divide both of the other 2 terms by 4. And yes, these are wonderfully manipulated. So you're going to end up with perfect squares all over the place. X plus 3 squared over 1 minus y minus 2 squared over 4 equals a 1. And there is our equation. All right. So now that we've got the equation, you got to figure out which way it goes. The x squared is first, which means we have a horizontal transverse axis. So my bells are going to be opening left and right. Good to know. Number 2, I need my center. Opposite from what you look at, it's -3 for the x, +2 for the y. Number 3, you need to find a and b. A always comes first, so a squared equals 1. Take a square root, you get a equals 1. B squared always comes second, so b squared equals 4. Take a square root, b equals 2. All right, this is a good time to go over and start the graph. You're going to want to put your x-axis kind of just below the hole in the paper. And then you can move your y-axis quite a bit over to the side. And then plot your center. 3 left, up 2. And this is going to be tight, so you probably should draw an arrow and do a -3, 2, kind of out of the way. All right, the A was under the X, which means you go right and left. My A is 1, so go 1 to the left and 1 to the right, and label them with our coordinates. So on the left, V for vertex, -4, 2. On the right, V for vertex, -2, up 2. Those do need to be labeled specifically, the center and the vertices. Okay, your B term was under the Y's, so you're going to count up 2 and down 2, and that provides you with the sides of your box. Okay, so we're going to draw our box. Whoops, and I put this in the wrong spot. We're going to draw our box and then draw our asymptotes. Remember, the asymptotes go corner to center to corner. They are dashed. They have arrowheads. Once you have your guide box and you have your asymptotes, now you can draw your bells. Remember, they're from the vertices, left and right, so kind of flat, skim the corner, get really straight. Kind of flat, skim the corner, get really straight. Again, your bells do not encroach upon the box. They are outside the box, touching only at the vertices. Okay, we pretty much have the drawing now, so it's only a matter of finding the foci and then labeling the asymptotes with their equations, and then you're done. So let's do foci. So remember that for foci, your equation is a squared plus b squared equals c squared. I highly recommend you write that on every problem. So 1 plus 4 equals c squared, which means c squared is 5. Take a square root. C equals radical 5. And yes, we still get weirdo numbers for the foci. All right, so my foci are based off the center. So I'm going, the center is at -3. So I'm going to go -3 to the left. And then this is where your C values are going to go right and left. So plus and minus radical 5, and then the same K value as the center. So comma 2. Put a box around it. And you don't have to graph your foci, not unless it says specifically to do that. All right, last thing, we need the asymptotes. To remind you of your equation, y minus k equals, I'm just going to put m for slope, times x minus h, and then you solve for y. I'm going to make a little space here. All right, so I'm going to pick the positive one first. So my k is 2. So y minus 2 equals, okay, from the center to the corner, we go rise over run up 2 over 1. So the slope is 2 because it's 2 over 1 times x minus h, which is minus a negative 3, so x plus 3. And then you solve for y. So distribute the 2. So y minus 2 equals 2x plus 6. Add 2 to the other side, you get y equals 2x plus 8. If you drew a careful graph, you will see that your asymptote actually crosses at 8 right up there. So if you know the slope, you can skip directly to that part. All right, let's do the other one. So we're going to go same start, y minus 2 equals, and then rise over 1. We go up 2 and to the left 1. So 2 over, up to, yeah, so 2 over a negative 1 is a negative 2. Times x plus 3. And we solve for y. So y minus 2 equals negative 2x minus 6. Add 2 to the other side, we get y equals negative 2x minus 4. And again, if you drew your line carefully, you can see it crosses 1, 2, 3, 4 right here at negative 4. And those are your asymptote equations. And you can either label them on the side or on the graph. If you're going to label them on the graph, put them at one end of the asymptote, so with a box around it. So y equals negative 2x minus 4, put a box around it. And then this one would be y equals positive 2x plus 8, draw a box around it. And we are done. Any questions?